Hello class, and welcome to today's algebra lesson, which is about parallel and perpendicular lines. By the end of today's lesson, you will be able to write equations for parallels and perpendiculars. So two parallel lines are two lines that do not intersect, and this is because they have the same slope. So for example here, these two lines that you are looking at is 1/2 x plus 3. So we go up 3 and then up 1 and over 2. And 1/2 x minus 2. So we go down 2 and then up 1 and over 2. So those parallel slopes, those matching slopes of 1/2 are what guarantees that those two lines are never going to intersect. They keep going up 1 and over 2, but they have different starting points, so they never get any closer together. Perpendicular lines are particular kinds of lines that intersect with each other exactly at a right angle. So they touch each other at exactly a right angle, and their slopes are what we call opposite and reciprocal. Opposite, meaning that one of them is positive and one of them is negative, and reciprocal, meaning that the numerator and the denominator have been flip-flopped. So in this case, the one on this graph, once again, the starting one is 1/2 x plus 3, so up 3 and then up 1 and over 2. The perpendicular line then for this one is y equals negative 2x minus 2. So we've got a negative 2, and then our slope is down 2 and over 1, or up 2 and left 1. So we have that intersecting line at a right angle. So now we're going to first just look at practicing the parallel and perpendicular slopes. So if our original slope is 7/8, the parallel slope is also going to be 7/8, and the perpendicular slope is the opposite reciprocal. So because the first one was positive, the next one is negative, and then the reciprocal means to flip the numerator and the denominator. So our perpendicular is negative 8/7. If I come to this next one, if my original slope is negative 3, my parallel slope is also going to be negative 3. My perpendicular then would go from negative to positive, and from 3 over 1 to 1 over 3. I want you to go ahead and try to find the parallel and perpendicular slope for negative 9/5 on your own. So negative 9/5 is the parallel, that stays the same. Positive 5/9 is the perpendicular. Now I want you to go ahead and find the parallel and perpendicular slope for 1/6 on your own. Parallel staying the same at 1/6. Perpendicular flipping over and changing the sign. You could have negative 6 or negative 6 over 1. Both of those are the same thing. So now that we've looked at the slopes individually, we're going to move into the part where we actually write the equation. So write the equation for a line in slope-intercept form. Remember that that is the y equals mx plus b format. That passes through the point 8, 9, and is parallel to y equals 3/4 x minus 2. So we have a point that we can use, and then we need to pick out the slope. So we're going to look at our original equation and pick out our slope, which is 3/4. So I have a slope of 3/4 and a point of 8, 9. I'm going to start by writing this in point slope format because we're given a point and a slope. So I'm going to say y minus 9 is equal to 3/4 times x minus 8. But then I need to get it into slope-intercept form. So I'm going to go ahead and distribute to get rid of those parentheses. So I've got y minus 9 is equal to 3/4 x, and then 3/4 of 8 is negative 6. Then in order to be in slope-intercept form, I need the y by itself, so I'm going to add 9 onto both sides of my equation, and I get that my parallel line is that y is equal to 3/4 x plus 3. So we have that value with our same slope, but different y-intercepts. Go ahead and try this one on your own. Your parallel slope this time keeps it the same at 2. We plug our point and our slope into our slope-intercept form, distribute, and add the 5, and I get my parallel line is at y is equal to 2x plus 11. The next piece is going to be to find the missing value. We want a line that passes through the point 5, 6, and be at 10n, and is parallel to negative 2/5 x plus 6. What is the value of n? Once again, recall that parallel means that our slope is the same. So now I need to set these 2 points up into the slope formula so I can determine when the slope is the same. So I'm going to take, and I've got n, first I should label x1, y1, x2, y2. So I'm going to take y2 minus y1 over x2 minus x1. When I reduce that, I'm going to get n minus 6 is equal to, is over 5. So that's my slope. Because it's parallel, I want it to be set equal to my original slope. So equal to negative 2/5. And then you need to cross multiply to solve. So I have n times 5, which is 5n. I have negative 6 times 5, which is negative 30. And then I switch to the other direction, and I have 5 times negative 2, which is negative 10. In order to keep solving, I'm going to add 30 to both sides of this equation, and that gives me 5n is equal to 20. And I'm going to finish by dividing by 5 on both sides, and that is going to give me n, not m, n is equal to 4. Once again, when you are calculating these things, you could plug it back in, and I would see that 4 minus 6 is negative 2 over 10 minus 5, which is 5. Negative 2 over 5, or negative 2/5, is what we wanted for our slope. Go ahead and try this one on your own. So we set up and we calculate our slope. Then we have our original slope, which is 4, or 4 over 1. Then you're going to do your cross multiplying, and we get negative 1 times 4 is negative 4. Negative n times 4 is negative 4n, and then is equal to 4 times 1, which is 4. Continuing to solve by adding 4 and dividing by negative 4, you get an answer of n is equal to negative 2. Moving on to the perpendicular lines. So we want to write an equation in slope-intercept form that passes through the point 4, 5 and is perpendicular to 2, negative 3. When we do this, you're going to go ahead and pick out your slope again, but your current slope is 2. Now that we want a perpendicular, I'm going to say my perpendicular, this is the abbreviation for perpendicular, is this upside down capital T. So my perpendicular slope is going to be the opposite. So instead of positive, it's going to be negative. And then we're going to flip it over to 1/2, 1 over 2. So now that I have my slope and my point, I can write in point slope form. So y minus y1 is equal to slope of negative 1/2 times x minus the x1, which is 4. Then I need to get it into slope-intercept, so I distribute. We get y minus 5 is equal to negative 1/2 x, negative and a negative make a positive, and half of 4 is 2. And then we're going to finish up by getting y by itself, in this case adding 5 to both sides, and I end up with a final equation of y is equal to negative 1/2 4x plus 7. So we've got the perpendicular slopes. One is positive, one is negative, and then the fraction or the whole number is flipped over. Go ahead and try this one on your own. Taking that slope, making it the opposite reciprocal gives you a -4. Plugging in the slope and the point, distributing, and then adding 7, we end up with y is equal to -4x plus 23. The last piece is going to be to classify the lines. This is determining whether they are parallel, perpendicular, or neither. So in order to do this, we need to be able to pick out the slope. In this first equation, 3y is equal to -4x plus 6. We can't pick out the slope yet because y is not by itself. So I'm going to divide everything by 3, and I'm going to end up with y is equal to -4/3 x plus 2. So from there, I can pick out that my slope is -4/3. In the second expression, we already have y by itself, so I can pick out my slope directly and get my slope is equal to -3/4. Those two values do not match, so it is not parallel. For the perpendicular part, they are reciprocals. The bottom and the top get flip-flopped, but they are both negative, so they are not opposites. Since they are not parallel, nor are they perpendicular, the relationship between these two lines would be neither. They are not perpendicular and they are not parallel. Go ahead and try this one on your own. So your slope for the first one is just -5. Your slope for the second one, you could rearrange by subtracting 25x on both sides and then dividing by 5. There is a shortcut. If you are in standard form, your slope was equal to -a over b, and that's how I showed my work here. In both cases, the slope is 5, so they have the same slope, which means that they are parallel. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.